Okay, so starting a new topic now, circular measure. A little bit. This is related to mensuration. The topic of mensuration you did in your O level, IGCSE. What was in mensuration? Finding the area, perimeter, surface area. The 3D figures are not right now relevant over here. Circular measure is more about the 2D figures, all about the cycles, arcs, what do you say, the quadrants, and circumference, and arc length, and sector, segment, all of these things. Find the area and perimeter, and all of these things are included in this circular measure and related to mensuration. Circular measure, definitely the majority part, the most important thing in this would be related to definitely circles. So you should be well aware of all of the geometric properties of circle. We should know about all of the terminologies, the chord, the tangent, all of these things. Geometric and angle properties as well. If you can recall these as well, if you remember these, then this would help over here as well. Angle properties of circle as well. So what is a circle? Circle is simply like this. It has a center, and what is called a sector? A slice. A slice of this what do you say? Pizza. This theta. This is called your sector, and this is your minor sector, smaller one. These terminologies they would use in the question, so you should understand what is a sector, what is a segment, and this one is the major sector. I know you people know about this. This is the radius, and we know it is a constant. This would also be the radius, and this is the center O, right? And what about a segment? If you have a circle and this line, what is this line called? Anyone who knows about it? What is this line called?
Chord.
Yes, good. This is a chord. Chord is a straight line which is passing through 2 points on a circle. So the 2 points are, let's suppose this is A, this is B. So this is a chord, and the chord separates the circle into two parts. And what is this part called, Sanchi, if you can recall? What is this portion called? Yaad? This is called a segment, and this is the minor segment right now because it's the smaller one, and this is the major segment. Major segment and minor segment. The chord divides the circle into two parts: a smaller segment and a major segment. And if you join it to the center, what will this form? This is forming an isosceles triangle because this is also the radius, this is also the radius. So this triangle AOB, this is an isosceles triangle. And if you drop a perpendicular from the isosceles triangle, from the vertex of the isosceles triangle, it bisects the chord perpendicularly like this. So if this is point X, so AX and AXB would be equal. Okay. So this is how, and it is bisecting the chord, the perpendicular from the center to the chord. It is always bisecting the chord. Always. You have to memorize, you have to learn, you have to use this property as well. They won't tell you if this property is applicable or not. You have to identify, you have to analyze the shape, whatever that they have given you. And you have to see if this is possible or which other property. This is a very common property that you will use. Another one. All of these things you have done in your O level as well. In your IGCSE O level. If you have, let's suppose, Munib, what is this line called? which is
Tangent.
just, yes, tangent. And what is the property? Can you recall the property of the circle and its tangent? Sanchi, याद है कोई property?
Base and tangent make 90-degree angle.
Hmm. With the radius.
The radius
With the radius, yes. A circle, radius, and the tangent at a point on the circle. They both are always perpendicular. Now they won't label you this 90-degree. You have to identify the shape. They will tell you that something is tangent to other, and then you will use this 90-degree property. Similarly, you have other properties as well. So many others. We'll revise all of those as well. But those angle properties and the geometry properties you should. And triangles, especially triangles also. You have two, three types of triangles. Right angle triangle. If you have a right angle triangle, then only you can use SOHCAHTOA, the basic trigonometric ratios, and you can use the Pythagoras theorem only if the triangle is a right angle. Right angle triangle means that it has a 90-degree angle inside it. This is a right angle triangle. And if it is not a right angle, something like this, anything else, not right angle, then for this type of triangle, you can use the sine rule and the cosine rule. We will use and revise this as well, because all of the geometry properties that you learned in your O levels IGCSEs can be applied over here. So you have done sine rule, cosine rule in your IGCSEs O level as well, and these sine rule, cosine rule can work with the non-right angle triangles as well. If the triangle is right angle, then only you can use the SOHCAHTOA and the Pythagoras. If it is not right angle, then you use the sine rule and the cosine rule. These things are very very basic things, and I know that people can forget, but this is just a reminder. Revision. Right angle triangle. And for the area of triangle, what is the formula for the area of triangle? क्या नाम है अपना Monip?
जी सर क्या पूछे? एरिया ऑफ ट्रायंगल वन और टू बेस इनटू हाइट.
Is there any other formula?
साइन साइन लगेगा.
1/2
साइन थीटा.
A B sine C. This is for the two formulas for the area of triangle. What is the difference? Why when will you use AB half base into height, and when will you use half AB sine C? Do you know?
तो जब हमें एंगल गिवन होगा तो
Okay. Yes, that's possible. The base and the height in this formula. The base and the height in this formula, they are always are perpendicular. Always. If the two dimensions of the triangle that they have given you, they are not perpendicular to each other, then you cannot suppose them to be the base and the height. You cannot use the formula, this formula. For example, in this one, let's suppose this is 5 and this is 3, this is 4, this is 5. Right now in this one, I can suppose that this is my base and this is my height. Why? Because I can see that the base and the height, the two dimensions 4 and 3, are 90-degree perpendicular to each other. That's why for this thing, for this triangle, I can use this half base into height. Can be used. And you don't have any other formula, you don't have any other dimension, oh, sorry, angle So that other formula cannot be used. Half into AB sine C. For this triangle, if you have, let's suppose this is 7, this is 8, this is 10 something. Now, if you consider this thing as your base, if this is your base, if you consider this thing as your base, 8, then your height will be this perpendicular distance to the maximum point. If this is your base, so your height will be this distance, perpendicular distance from the topmost point on the triangle to the base. And you don't know that, you don't know the height of this triangle. So that's why you cannot use the this formula, half base into height. For this form, for this kind of triangle, they may have given you a theta value, and then you can use half AB sine C. Now in this type of triangle, if you don't know the base and the height, then you use this half AB sine C. And how does this work? Half AB sine C works like a V. This is your V shape, and for your V shape, you should have two adjacent sides and the angle in between them. Then you can use half AB sine C. Half AB sine C will be used when you have two adjacent sides and the angle in between them. The angle in between is your C angle. Half A and B are the sides, and the angle between those two sides is your C. So let me write this down as well. Adjacent sides and angle between them. Then only can you use this half AB sine C. So these are some things you have done in your O levels IGCSEs. They will be carried forward over here. They will be used over here. Okay. Okay, all the previous angle properties also you should recall. Okay, you should revise angle properties, the straight line property, the Z angle, the Z property, F property, C property, X property, all of these properties as well. These are when your lines are parallel line properties. Yeah, you these can also be applied over here. Okay, and all of the circle properties as well can be used. So overall, generally, overall, whatever that you did in your in your IGCSEs for the chapter of geometry can be one way or other be applied over here, can be used over here. So revise the complete chapter. I'll share you some notes of this. Otherwise, this topic is purely based on the things that you did in your O levels, in your IGCSEs. If your geometry over there was good, then this topic won't be an issue for you. Now, what is new? Okay, one more thing to revise, and then we move on to the new part. What is new in this chapter? About the circles, we have the area and perimeter of a circle. Formulas: pi r square and 2 pi r. Perimeter is the sum of all external sides perimeter. And if you have a sector, now we know what is a sector, a slice of a pizza. And if you want to find the area of a sector, the formula we did in our O levels IGCSE was theta upon 360 multiplied by pi r square. And over here, theta upon 360 multiplied by 2 pi r. This would give us the circumference plus the 2 radius. This thing is the circumference, the arc length. This is your arc length. If you have a sector like this, so this is the angle of the sector theta. This is the radius. This is the radius, and this part is the arc length. This is your arc length. And if they talk about the perimeter, perimeter is the sum of all sides. So there is the arc length and there are two radius. So that's why this arc length plus 2r. And this is the circumference. 2 pi r is the circumference of a circle. We have done these two formulas as well. Now what is new? New part is, first of all, you will learn a new angle property. Oh, sorry, angle unit. A new unit of angle. What is the new thing in your AS? So you have done angle units. One of the only angle units right now that you have done is the degrees, right? 360 degrees, 180 degrees. Now you would learn radians. So this is just another angle unit, just like degrees. This is another one, radians. And how do you convert? What is the relationship between them? The most basic conversion between them, the relationship between degree and radians, it is pi radians. It is equals to 180 degrees. This is it. This is the most basic relationship between them. And then using this thing, I can I can find other. For example, how much is 90? How much is 360 degrees? How much is 270 degrees in radians? So we know that in radians and in degrees. Let's convert a few. We know the basic one is pi is 180 degrees. So if I talk about 90 degrees, you can see it is 180 divided by 2, which is 90. So this would become pi by 2. If it is 360 degrees, then it is twice of 180. So this would be 2 pi. If it is 720 degrees, which is 4 times of 180, so this would become 4 pi. If this becomes 60 degrees, which is one third of 180, so this would become pi by 3. If you write 30 degrees, it would be pi by 6. 180 divided by 6 is 30, so pi by 6. If you want to write 15 degrees, it will be pi by 12. If 45, you want to write 45, it would be pi by 4. 45 is 180 divided by 4, so pi by 4. Okay. Or one more thing, if you want to write how much is 1 radian in degrees, it is 57 point something, 57.1, or let me confirm. I forgot it. 180 divided by pi. 57.295, 57.3 something. So 1 radians, it is 57.3 degrees. This is just another angle unit. Now you will see in the questions they won't use degrees, they would use radians. So it's nothing different. You work, everything is the same. You just now use the radians. That's it. Nothing new. And now, according to this radians, the new angle unit, you will now convert a few formulas. Now, in radians, the formulas over here for the sector area and for the perimeter area, these were when your theta is in degrees. But now I can change. I can modify the formula in front of you. I will modify it, and then we will derive new formulas in terms of radians. Okay. So it is 360 degrees, 360 degrees. If I talk about the theta now, it is in radians. So 360 degrees it is just right now. 360 degrees, 2 pi. So I will replace the 360 with 2 pi multiplied by pi r square. So this pi and this pi cancel out. So you are left off with 1 upon 2 r square theta. Now in this one, the theta is in radians. And over here, theta upon 2 pi multiplied by 2 pi r. So this and this cancel out. So r theta, this is your arc length. This is the area of sector, new formula for the area of sector. And this is the new formula for the arc length. And now the new symbol or the new, what do you say, variable that you would use for arc length, it will be s. So s is equals to r theta. These are two new, and if you two new formulas, and if you simplify, if you replace the r theta over here in this formula, it is look r half r square theta, right? So r and r theta I can separate it. So half r into r theta is left off, and r theta is s. So half rs. This is another formula. So these are the three new formulas that you will use, learn for the area of the sector and the arc length. And now in this case, your theta is in radians. Okay, these formulas, copy down these formulas. These are important. And the simple conversion, and then you can use simple cross multiplication if need be to convert. Otherwise, everything would be in radians. Okay, so you don't have to worry. One more thing: when you use a sine, cos, tan, when it is radians, you have to convert your calculator into radian mode. Right now, it is in degree mode. It is now in radian. This is gradient. This is degree. This is radian. So when you put in, look, we know the sine 180. Sine 180 is 0. If it is in degree mode, sine 180, it gives me 0. And now if I change it into radian mode, now I would write sine pi. Again, it is giving me 0 because pi is 180. So I convert it into the radian mode, and then I use the pi inside the sine and the cosine or whatever that you want to use. Similarly, 10, let's suppose 1045, it is 1 in degree mode. 45 degrees, 10, 45 degrees, it is 1. And if I want to do the same thing in radians, I know 45 is how much? Pi by 4. So in degree mode, 10 pi by 4. Sorry, it is pi by 4. So look, it is again giving me 1. So you have to convert your calculator to radian mode whenever you are using sine, cos, tan with the radians. Okay. Okay, I'm giving us a small find the area and perimeter of shaded. Okay. So look, they have given you this shape The shaded region is in front of you, and we will use the geometry, simple geometry rules and everything, and find the area and the perimeter of the shaded. First of all, let's find the area and break it down. For the shaded region right now, area of shaded, first identify what shapes will you use to find that. So what can I do? First of all, I can take the sector, right? The complete sector minus the triangle, the right angle triangle I can see. So I will get this part, the shaded part. This is your complete sector. I will find the area of the complete sector minus the area of the triangle. I can get the area of the shaded. So sector formula, the area of sector formula we just learned, it is half r square theta. When your theta is in radians, and right now you can see it is in radian. Minus for the triangle, I can use half AB sine C or half base into height. We don't have the base, we don't have the height. The base and the height, we know they are perpendicular for a right angle triangle. And right now, it's better. I think we should use half AB sine C, because we can find two adjacent sides and the angle in between them. So if I just find this side, I will have the two adjacent sides and the angle in between them 1.2 degrees radians. So putting in the formula half r square theta, so half radius is 6 square and theta is 1.2 minus half into 6 into, we don't know the base, we will find this, into sine 1.2. Now I can use SOHCAHTOA, basic SOHCAHTOA, to find the base of this right angle triangle. So I can use cos, I think cos of 1.2 radian is equals to adjacent. Let's call this x upon hypotenuse, which is 6. So x will be 6 cos 1.2. So this I can replace it over here, 6 cos 1.2. Or I can use the calculator first, okay. In radian mode, 6 cos 1.2, it is equals to 2.174. So I can use it over here, 2.174. And now 0.5 into 6 square into 1.2 plus 0.5 into 6 into 2.714 times sine 1.2. So the answer of the area of the shaded is 29.188. So 29.2.
माइनस होगा ना, आपने प्लस किया है.
Yeah. Minus, yes, yes. Typo. Okay, 14.9 is good. 14.01, which is 14.0, you can say. So you use half of AB sin C for the area of the shaded. Now for the perimeter we know it is the sum of all external sides. So how many sides are there? You have to identify first of all. This is the side of the shaded. This is the side, and this is the side. So these three sides, if you add them up, you will get the perimeter. So this, you have one of them is the arc length. Arc length is r theta plus the other one, this part. This we can easily find because it was the sector. So this and this, these two are radius, right? Both of these are radius. So both of them would be same. If this is 6, this complete thing would also be 6. And we have found this 2.174. So this means this part, it will be 6 minus 2.174. And for the height of the triangle, I can use sine 1.2 is equals to height upon hypotenuse 6. So h is 6 sine 1.2. So I will use this plus 6 sine 1.2. R theta, the radius is 6 and the theta is 1.2. Then use your calculator, that's it. 1.2 times 6 plus 6 minus 2.714. This is 714. 174. 174. I think I have used 714 on the previous one. Let's check. Plus 6 sine 1.2. So you have this parameter, the sum of the three sides, 16.6. This is your final answer. Look, it is 15.52. This is how you would solve. This is a very past paper like question. You have many questions like these. Look in this one, look at this one, look at this one. In terms of r, in terms of theta, everything. The diagram shows a sector ABC. It is a sector. And the English over here given the information, it can also help you out a lot. A lot. So this is a sector. This means this is the radius, and this is also the radius. Because ACB, this is the sector. So if this is the radius, this would also be the radius, the AC. Center A, radius R. The line BD is perpendicular to the AC, as we can see. CAB, it is theta. Okay. Given the theta is, okay, find the exact area of BCD. They want the exact area of BCD, this part, in terms of R. Okay, we know the theta. So we know it's very similar to the last question we did. So area of the BCD, it will be area of sector minus area of triangle. Area of sector is half r square theta. So half radius you don't know. R is r square, and theta is pi by 6. They have given it to you. Pi by 6. And minus area of triangle. For the area of triangle, we need, you can use half AB sine C. So for that thing, you would need to find this. And for this thing, you would need to use cos. So this would become cos theta, which is pi by 6, is adjacent, which is AD, upon hypotenuse is R. How much is cos pi by 6? Muneeb or Sanchi, use a calculator. Convert your calculator to first radian mode and then cos pi by 6.
Under root 3 upon 2.
Root 3 by 2. R. This is your AD. So this would become the area of triangle. It would be half AB sine C. So half ABR and root 3 by 2R into sine pi by 6. The two sides and the angle between them. R and root 3 by 2R multiplied by the sine of the angle between the two sides that you know. And now you just have to simplify this thing. So this would become pi r square upon 12 minus this would become, how much is sine pi by 6? This would become root 3 by 4 r square, and sine pi by 6. How much is sine pi by 6? It is, I think half, 1 upon 2. Sine pi by 6 is 1 upon 2. And then, so 5 pi r square upon 12 minus root 3 by 8. R square. This is your answer. The area of the shaded, the area of CBD or BCD in terms of R. You can take R common as well, okay? It's okay. You can give it like this as well, or if you want to take R common, that's also okay. Then, second part, given that the length of BD for the second part they have given you, BD is root 3 by 2R. So this is root 3 by 2R. Find the exact parameter of BCD in terms of R. Perimeter of BCD. Perimeter of BCD, perimeter of BCD. We need to find this thing and we need to find the arc length, right? We know that the total thing is this would be radius, right? This complete A till C. This is radius. So if I take the triangle ABD, this part B, I'm doing part B now. ABD is a right angle triangle. ABD. So you can use Pythagoras theorem to find AD. If you find AD, then you can subtract it from R, you will get CD. R is the complete A till C. So if you find AD, subtract it from the total, which is R, you will get CD. So AD you will find using Pythagoras. So hypotenuse square is radius square, R square, hypotenuse is your R, and then root 3 by 2 R whole square plus AD square. Let's simplify this thing. R square 3 upon 4 R square AD square. The R square minus 3 upon 4 R square is equals to AD square. This would become R square upon 4 AD square, and therefore your AD would become square root. So R upon 2. So AD is R upon 2. So this is R upon 2. So definitely CD would also be R upon 2 because total is R. This total is R. This much is, we have found out R upon 2. So definitely this would also be R upon 2. Don't go on the looks, okay? It doesn't look like it's half, but the values are telling me by simplification and everything. It's telling me that the ADC, ADC, the D is midpoint, you can say. R upon 2, R upon 2. And now you want to find the CB. For that thing, you need to find the theta value, R theta, right? This is R theta. The formula for the arc length is R. You don't know theta, but you don't know R as well. So we can use the right angle. Again, this right angle triangle, and we can find the theta value. So this is your right angle. This is R. This is root 3 by 2 R, and this is R by 2, and this is your theta. So you can use cos theta, it is equals to adjacent upon hypotenuse. R and R cancel out, so your theta will be cos inverse of half. And this would be in radian mode. How much is this? Use your calculator. Cos inverse of half. It will be pi by 3, I think.
1/3 pi.
Mm, this is pi by 3. So now you have the value of theta. And so your arc, this would become r theta, which is pi by 3 into r. This is your arc length. You have found your arc length, r theta. And so the complete thing would become root 3 upon 2r plus r upon 2 plus this pi by 3 r theta. So if you want to take r common, this is the parameter. So it was exactly the same thing but the difference was you don't know R. Everything was in terms of R. So simplification can be a little bit complicated, but otherwise, no new property that you have used. It was the same old geometry, SOHCAHTOA, half AB sin C, perimeter area, and a little bit of algebra simplification, and that's it. You have answer. सही है, समझ आ रहा है संची मुनीब? Do you get it?
Yes, sir.
Yes, sir.
They won't be very difficult, but the simplification sometimes or understanding the shape sometimes it can be difficult. But overall, you have done all of the rules, you have done all of the properties, geometry, circle, triangle, everything. So it will be within your expertise. Hopefully, you just need more practice, more revision, and pass paper, pass paper, pass paper. I can copy this down, take a screenshot. I'm stopping the recording now.